In this example, we're going to take a concept that most of us are familiar with, and that is looking at the max capacity of an elevator. So, suppose that we have an elevator with a maximum capacity of 16 passengers and a total weight of 2,500 pounds. Assuming the worst case scenario in which the passengers are all male, what are the chances that that elevator is overloaded? We will assume male weights follow a normal distribution with a mean of 182.9 and a standard deviation of 40.8. So I'm going to just write down some information that was given to me to begin with. In the very last sentence, we know that the population has a normal distribution and that the mean of that is 182.9 pounds, standard deviation is 40.8 pounds, and that this comes from, that this is, I should say, a normal distribution. So it's not skewed like our previous example. We are asked to find the probability that a randomly selected male has a weight greater than 156.25. So what is the probability that some man, X, has a weight greater than 156.25? Well, before we go too far, I want to just quickly explain where did we get the 156.25? It's not exactly clear in the problem, but it's actually specific to this particular problem. Why are they randomly choosing? And they didn't randomly choose, but where did the 156.25 come from? If you look back to the very first sentence of the example, if we have a passenger car that has a maximum capacity of 2,500 pounds, and a maximum capacity of 16 people, 2,500 divided by 16 is 156.25. So that's where this number comes from. We are using that as the basis of our probability statement. So find the probability that some man, one randomly selected male, has a weight greater than 156.25. In this set of problems, it's important for us to understand, is my question about the population, or is this a question about a sample? And from the first bullet that we're looking at here, this is a question about the population because I'm not clear on a sample of so many men. It doesn't say that anywhere in that sentence, so I'm assuming that this is a question about randomly selecting one person out of the population, one man out of the population who weighs more than 156.25. So that means that I'm going to use the normal calculator, and I'm going to use a mean that was given to me about the population of 182.9, as well as the standard deviation of 40.8. So over here in the calculator, we're going to put in 182.9. Our standard deviation is 40.8. And we're looking for the likelihood of some man weighing greater than 156.25. Hit compute, and you can see that there is a 74% chance, or the proportion of times that happens is 0.7432. So it's a 74% chance that you're going to randomly meet some person off the street, some man off the street who weighs over 156.25. Now the second part of this question says, find the probability that in a sample of 16 males, that their average weight is greater than 156.25. So this is a question about a sample. And we are told that we have a sample size of 16 men. And now we want to apply our normal model. So we want to make sure that we have met the criteria for the shape. So the shape of our sampling distribution Well, it comes from a population that's normal, so the sample distribution will also be normal. So that's good. The center of my sampling distribution says that the mean of the sample means is equal to the mean of the population, or 182.9. And the spread is the standard deviation of the sample means, which is equal to 40.8, which is the standard deviation of the population, divided by the square root of our sample size of 16. And that's going to be 10.2. We'll use 10.2 for our number. So once again, I'm looking for the probability that a sample of 16 men, that their average weight is greater than 156.25. And so we're going to change our standard deviation in the calculator over here. Let's get rid of the 40.8, and we will replace it with 10.2. We don't need to change anything else, but when I hit compute, now look what that shows. This says that 0.9955, it's a 99% chance that if you have 16 men together, their average weight is going to exceed 156.25. So in other words, if I have this group of 16 men together on the elevator, they are now, it's a 99% chance that they're going to exceed the max capacity. So here is an interpretation of what we were just saying. While there is a 0.7432 probability that in any given male will weigh more than that 156.25 weight, it's a 0.9955 probability that a sample of 16 males will have an average weight greater than that. So if you have a elevator filled to the capacity with all males, there's a very good chance that the safe weight capacity of 2,500 pounds will be exceeded. Kind of a fun example.